Calculus often feels like a bunch of rules to memorize. But what if you could have invented it yourself?
So, let's explore this simple geometry problem. You might be surprised just where it takes us.
The goal here isn't just to find the answer. It's about the journey, how you could have discovered it.
All right, let's start with a circle. To find its area, we're going to need a clever strategy.
The big idea is to figure out the area of each ring and then just add them all up.
Okay, let's zoom in on just one of these rings. What do you think happens when we unroll it?
When you unroll it, you get something that's basically a rectangle. Let's break down how.
So the length is easy, right? It's just the ring's circumference, which is 2 pi r.
And what about its thickness? Well, we'll call that tiny change in the radius dr. So, the area of one of these little rectangles is just its length times its thickness, 2 pi r times dr.
Okay, this is where it gets really cool. What if we stack all those little rectangles side by side? See how each rectangle's height is based on its radius? When you line them up, a new shape emerges.
And if you make those rings super, super thin, those rectangles perfectly form a triangle.
And we all know how to find the area of a triangle, right? The base is r, the height is 2 pi r.
Do the math, and what do you get? A very familiar formula, pi r squared. And that's it.
This whole technique, summing up infinite tiny pieces by finding an area, that's a core idea called an integral.
Okay, that worked for a straight line. But what if you have a curve, like, say, y equals x squared?
Let's switch gears. Instead of the total area, how does it change from one moment to the next?
Well, that tiny sliver of area, dA, is basically a rectangle, height x squared, width dx.
So the change in area divided by the change in x is just the height of the curve x squared.
And that idea, measuring an instant rate of change, is the other big piece of calculus, the derivative. So think about what we just did. We asked two totally different questions, one about sums, one about change.
Right. The integral is all about adding things up. The derivative, it's about how fast things are changing.
And here's the big punchline. They're opposites. The derivative of the area gave us back the original curve.
This is the fundamental theorem of calculus. It's the master key connecting these ideas, making hard problems simple.